This is my Lab 2 lines of charge. It is a follow-up lab for Lab 1. The only difference between Lab 1 and Lab 2 is that in Lab 1 we treat each tape as a single charged point located at the center of the tape. So basically, we discuss the interactions between one single point charge to the another single point charge. But in Lab 2, we distribute the charge evenly across each tape as a line. The physical principle used here is first the Newton's second law. For the top tape, it experiences two forces, the gravitational force and the electrical force, and the sum of them will be equal to 0. And then we use the physical principle, Coulomb's law. Electrical force will be equal to the charge of the top tape times the net electrical field it experienced. For the line point model, we will calculate the electrical field a little bit different. That we will count each charge of the bottom tape to each charge of the top tape. For the experiment from the Lab 1, we get the value that the tape length will be equal to 0.2 meters. The tape mass will be 2e to the negative 4 kilograms. The distance will be 0.04 meters. The magnitude of the gravitational force is equal to the magnitude of the electrical force, which is equal to 1.06 e to the negative 3 newtons. For this line charge model, I first have to estimate the charge of each tape. I tried different charges, and finally I find that use the estimated charge I listed here, we will find the electric force and the gravitational force to be most close. This is the computational model that I create. First, I insert all the value measured from Lab 1, and then I try to create a function for the electric field. This function is exactly the same with the function that I create in Lab 0. After that, I will simulate the number of the charge n to be 10, and I will use the loop to iteratively calculate the electrical field and electrical force exerted by each bottom charge on each top charge. Finally, I will add the electric field and the electric force respectively to get the final result. This is the result of my computational model. You will find that the yellow arrow is the net electrical force, the bottom tape exerted on the top tape, and the white arrow is the net gravitational force the Earth exerted on the top tape. You will find these forces add together will be very, very close to 0. Here's my answer to what if and the why question. First is that what is the difference between the point charge model and the line charge model? In the first lab, the value of the point charge model is the charge of it is 1.87 e to the negative 8 coulombs, while in this lab, the value is 1.07 e to the negative 8 coulombs. The values of the two labs are largely constant, but the point charge model creates a value about 1.7 times larger than the line charge model. And the next question is, what is the difference? Why they are different, and which one is much more closer to the real value? I think the line charge model produces a result much closer to the real value. In the real setting, all the particles on the bottom tapes will interact with all the particles on the top tape. But the point charge model simplified the interaction to be one point charge floating above another point charge. In the line charge model, we actually simulate each tape as a single line of the charge and deal with the interaction between each bottom tape charge and each top tape charge. So it will be much more closer to the real setting, although it's not exactly the same with the real setting because we treat it just as a single line. And here is my code link, and thanks for watching.